Hello and welcome. I'm waiting for some stuff to come in from China, so I'm going to be downgrading my quadcopter back down to the APM 2.6. So I thought I would take this opportunity to make a little better step-by-step than my other video and to answer some of the questions that people have been asking me. One of the main ones is, well, not one of the main ones, but one of the questions is what's the difference between the stock APM and the APM 2.6 or 2.8? And basically nothing. The quadcopter kit comes with a GPS Neo 6M. This black guy, if I can get into the camera here. This guy here. And that's basically one of the biggest benefits is the GPS. Besides that, the two APMs do exactly the same thing. The reason why I upgraded is because my barometer on this one had screwed up and caused my quadcopter to go above the tree lines and come crashing down. So I ended up having to replace it. The bonus of this one though is it has all the extra pins here for easy access, your telemetry right there, your power module, the ITC port, the GPS. It's just a better system for plugging things in. Besides that, everything internally is basically 100% identical. So if you don't have any issues with your current APM, if it's an open source, you don't really need to upgrade unless you're going to start adding sonar and start playing with the pins a little bit more. And that's it. So I'm going to jump into the build, I guess. Alright, so I got the case off. I got my Pixar's APM out of it. The kit comes with, like I said before, an APM, a power module, and a Neo 6M GPS. I don't show in this video how to use your old compass and your old GPS. I'm sure it can be converted over really easily. I just never done it yet. The upgrade's worth it because the GPS comes with a built-on battery, so it just finds the signal a lot faster. Alright, so the first thing I'll get into is the wiring for the receiver. I have another video on how to center the APM. You might want to check that out, just so you know how much play you actually have with it, so you're not that nervous. In reality, you can mount it there if you wanted to, over here. Basically, Mission Planner will compensate for wherever it is. But anyways, I know, because I've already marked it for my other video, it can go back here somewhere. I'm going to leave everything loose during this build, just so I can lift it up and show you guys. I'd actually suggest too, probably be better not to glue this down yet, or anything down until you're totally done. It does look messy, and it might be a little bit confusing, but at least you'll be able to move all the wires around and then tie them up. I also have hot glue on everything, so you have to ignore that. So again, we're going to go by numbers. So it's AETR1, and those are the first 5 we're going to deal with. So just think of it as 1, 2, 3, 4, and 5. And that's for this top row. The middle row is your positive, and the bottom row is your ground. Your kit should have came with wires, or you can use your old wires. It's up to you. On the APM, where it says input, this is for the receiver, and here it goes 1, 2, 3, 4, 5, 6, 7, 8. So basically we're going to be dealing with 1 to 7. So the first one is the A. I'm going to use this wire for the first one. It's orange, red, and brown. And I'm going to put the orange on the top. So the top row is your switch row. So I'll plug this guy in there. That looks like that. And then this goes on the APM. Now the orange is at the top for the switch. On your APM, where it says input, the yellow row on all these is your switch rails. But for the receiver, we're dealing with that. So the orange would go at the top. So number 1 is your A from here. The reason why we're using a 3 cable is because depending if you're using a power module or you're using a power off the board, this unit gets powered either by the APM, or you power this unit and then this unit powers the APM. So that's why we use the positive and a negative here just for this one. So the next one is a white, black, and red, and this would cover 3 of them. So this would cover E, T, and R. Again, we're going to use the white first in this direction. And now white would become your number 2, number 3, and number 4. And that, again, that's on the top row. So the next one is your -1. And the way I showed in other videos to do it was I would put the white at top, and then I would use this cable and cover 4, 5, and 6. However, somebody in one of my comments asked me, why am I setting 5 volts to the APM? Because at the beginning of this video I told you the middle row is positive and the bottom row is negative. I only did it because that's the way my cx20 actually came, and a lot of them actually do come that way. I'm not sure why the manufacturers at cx20 did that. I traced it out, and it actually really does get connected to the Omega 32 chip on, I believe, PB5. It doesn't have any issues. I don't know if they did it so the chip wouldn't float. I have no idea. So because I don't have an idea, I went and edited all my videos, and now I would just suggest to take out the black and the red wire out of it. Alright, I'm back at removing the red and black wire out of this harness. So now basically this white one would go for your number 1. And then the white one here goes for number 5 on the input rail. Like that. If anybody can tell us why, or tell me at least why they had used the 5 volts in the ground, again, the only thing I can think is so the chip wouldn't float. A lot of CX20s do come with the 3 of them, so it's up to you if you want to add it to the number 6 and number 7. I flew it for over a year like that on most of my quadcopters and without any issues. But for now, I just suggest doing it this way until somebody can actually say why they did that. Okay, so I've spent too much time on this, so now I'll move on to the motors. Not sure if I mentioned at the beginning of the video, it was good to remove all your wires and just move them off to the side. Again, it's going to get messy, but just follow along with me. If you get confused, then pause it. Actually, before I jump on the motors, I'll just get the 2 gimbal wires out of the way as well. So this white one on its own would go for -2. And then you got this guy here with white and red, and that goes for the -3. And these are for your 2 gimbals underneath the quadcopter. So the only thing you're left with is now -B. So actually, before I jump onto the motors, I'll explain -B. This is kind of important. Alright, so if your quadcopter kit came with the power module, again, my power module is kind of hooked in here, so I can't really take it out to show you, but I'll show a quick picture of it right now, of what it looks like. I fed it underneath here. If you get confused what direction it goes in, just simply plug your battery into the end, because your battery won't plug into the other side, so you'll know which way to plug it in. So if you have the power module, it just gets plugged right into the APM on PM. This guy gets plugged in right there. Now you're left with the wire off the board right here, and it's a red, white, and black. So if you have the power module, it's really important that you tape this guy up and just tuck it away. If you want to use the plus and negative volts for something else, it's 5 volts. It's really clean, so you can use it for sonar or whatever. But besides that, just tape it up. Now, if you don't have the power module, alright, so this guy would get plugged into the B port, and the white at the top again, positive, and in ground. So because you don't have the power module, what's happening now is off this board here, the plus 5 volts is going to the receiver. It's on the positive rail here, and it's going back to the APM and now powering the APM through this cable here. But it's really important that you can't plug in both of them, or you can fry the quadcopter. or the motherboard or the APM. So it's important, just tape it up and tuck it away. JP1 and the other header here, or the jumpers, sorry, just remove both jumpers. JP1 is if it's basically meant for other quadcopters if you have a BEC. Some of the ESCs that come with the other quadcopters have something called a BEC, and what that does is powers the APM through the ESC. And that's why you'll notice each of these motors actually has a red wire just dangling there. The reason why now I suggest just to remove it, because once you enable this jumper, it actually powers up this middle row for 5 volts. And because on the cx20s from factory, at least on mine, all these red wires would then become hot. And I'm not sure if you can see that in the video, but they just dangle. So it has the potential of shorting out on something. So it's easier, just remove that jumper, save it away. I really doubt you're ever going to have to use it, especially if you have the power module, because you can use this in another quadcopter after if you want to. But anyways, so just remove JP1 and remove the other jumper. Okay, I'll get onto the motors now. If you're going to get confused with the motors, I would suggest taking a piece of brown tape or something, or even a felt marker, and just marking each section with the number so you'll never get confused. It's easy to get confused, like the Elmo quadcopter I actually build. I almost never ever screw up on the motor things, but I had actually had it all shift over just a little bit, and the guy kept on flipping over. So it is easy to make a mistake, even if you think you know what you're doing. So it's kind of better just to mark them down. But I'll show you guys the numbering now. So this is number 1, motor 1, motor 2, motor 3, motor 4. On the output of your APM, it goes 1, 2, 3, 4, 5, 6, 7, 8. We don't use all 8 of them because this is a quadcopter, not an octo. So we're just going to go up to number 4. Each one has 3 color codes on it. A switch, a positive, and a negative. As I said a minute ago, the positive one's not connected, so you don't really need it in there. But because we removed JP1, it won't be hot, so it'll be fine just leaving it like that. So number 1 goes into the number 1 of the APM. Again, the yellow is always your switch rail, and that's your white. So this guy gets plugged in this way, like that. So number 2, if I can find it. Right, so number 2 is here. Again, the white is your switch, goes on to yellow, and it goes right next to the first guy here. Number 3 is here. 3 wires again, white at the top for yellow. And your last wire, number 4, if I can find it in this mess. And that goes on number 4 on the APM, white at the top again. Alright, I'll go over the telemetry as well, telemetry, whichever way I'm pronouncing it wrong. If you did the mod and converted this cable for the original cx20, you're going to have to revert back to stock. If you forget the color codes, so on the APM on this side going that way or whatever, I got the black first, then the space, blue, yellow, red. It's really important that you switch it back over to this proper way so you don't fry the APM or the telemetry. Okay, the last 2 things, or 3 things, is the GPS or the USB cable. It's too short because the original had USB on this side. So you're going to have to cut the cable, find 4 pieces of wire, attach them, solder them, heat shrink them. If you don't have a soldering gun, you can just twist the wires on and tape them up with electrical tape or something. And then this guy just gets plugged into the USB. This is actually where I usually mount the receiver on it. Just keeps it out of the way. So one of the issues you'll have with this is all the wires might be sticking too much up. So when you go and put on the shell, the top shell, it might actually push the APM down. That's what I always suggest. Never ever calibrate your APM before you mount everything, because it's just a total waste of time. Little things like you might calibrate this with the accelerometers out of the shell with levels and everything like that. But once you put it in, even the lightest weight pushing down this way, it'll send the it'll screw everything up, so you have to redo it anyways. But it's really up to you guys. I would suggest just doing it after. Alright, so the last two things now is the compass and the GPS. There's two different versions of this APM, a 2.6 I guess and a 2.8. I think they might have different setups because I have a couple of other ones where it gets hooked up different. Now, most people say hook it up to the I2C port for the compass, and that's this blue and white wire. Oh yeah, I'll just go over this too a little bit. The compass. On the bottom of your Neo, it should have 4 screws. What you can do is just take off the bottom, move the wires to the middle of the motherboard a little bit better, and then you can just send the black wire right through this hole. So that's one way of doing it. Of course, I like my hot glue, so you can just glue the top of the lid on, and it holds really good. Okay, so the I2C, as I just said, some of them say plug here, and then I found out it gets actually on this one gets plugged in down here. So that's where mine gets plugged in. And then the GPS plugs in up here. Now I suggest first you can try this I2C port up here in Mission Planner if it says compass error. So like, don't screw the lid on or anything before you're done, because you want to test the motors, and you might have to calibrate the motors as well, or the ESCs. So try here first. If it doesn't work, if you get a compass error, no compass or something weird like that, just try plugging it in down here. You'll know right away too, because the other APM 2.6, this cable won't even fit in there. I think it has a 6-pin or a 5-pin. So this guy won't fit anyways. So you'll know you're doing it right. Alright, I made a whole separate video concerning the lights. That's one of the biggest problems with the conversion. Actually, the only real problem is the lights. Now, I believe on the original APM, they did ground as a switch, and then you would have, they did the ground as a switch, but this APM here does positive switch. So you're left with a couple of choices, is watch my other video, and I pretty much tried my best to explain it. You'll end up having, if you don't do the mod I did, what I ended up doing on these lights here is I flipped the diodes, the LEDs on them. I turned them around, so now I get all my 3 lights. But if you're not into that, you can just cut the wire and then just use the wire that you cut as another switch wire. And I'll try to explain that drawing it right now, because I don't have that cable. I actually don't have the LEDs that it seems to be coming with the new quadcopters. So I'll just try drawing this out really quickly. So some guy on my YouTube channel asked me for help, and I don't have his LEDs, but the way it basically goes on the black harness, so that's this plug here, but it has 4 wires on it. It goes white, I believe red, black, red. Now on mine, my quadcopter, it actually just had the red wire jumping over to the other LED. Where this one actually has 2 wires going in it, and they're joined together, and then these 3 wires here. Now, I don't have this, so I'm not 100% sure I'm right, but I'm basically 99% sure. Basically, the white, the red, and the black wire on the harness, those are now going to become your ground wires. And then these 2 that are coming in here, you're going to want to cut one of them and then add an end to it. One that you maybe saved from the receiver I had showed you. So cut this and add an end to it. So now your red one that had the 2 wires, what you'll want to do is just make 2 separate ends like that, and those 2 are now going to be your switch. So one's going to be for your GPS and one's going to be for your arming it. And your arming light goes into A7 and this guy goes into A6 on the APM. So I'll show that right now on the APM. And then the other 3 just go to ground. If you want to save cable or save space, you can actually join two of them to the third one just by skinning the wire back and just do that. But there's so many spare ground pins, you may as well just plug all three of them in. And I'm, like I said, 99% this is gonna work. All right, so A7 on the APM, you always start at 0. So it would go 0, 1, 2, 3, 4, 5, 6, 7. So this 7 right here is for your arming light. Now I've already done the conversion, so I'm going to plug my whole harness into it. So A7 is for your arming, and A6 right here is for your GPS. And then take your 3 ground wires. I only have the 2 because I flipped everything over by doing the 2 LEDs. And in this whole bottom row here, up to wherever you see the yellow is ground. So you can just plug it here. And to explain that a little bit too, this is your SPI right here, your port right here. So don't ever plug here or here for your positive or your negative down here. Just treat these last 6 pins as something totally separate, and you get the biggest hint because there's no yellow at the top of these two. Alright, plug in your APM and connect. Now if you have some settings on your old APM, I would suggest connecting your old APM. Go to config and tuning, go to full parameter list, and choose save to file. After you save it to file, name it something, then plug in your new APM, come back into full parameter list, and this time click load from file, and then click write parameters, and that will save all your old settings. But most of them you're going to have to go over again. That's if you tweak some of your settings. But anyways, I'll show you a couple of things in here quickly. In initial setup, if you're going to do a calibration or ESC calibration, go into mandatory hardware and go to radio calibration and do the calibration before you do the ESC calibration. Under flight modes, set them up like this. So the first one's RTL, second's alt hold, stabilize, 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 and then put a check mark in simple mode. And the last one, put loiter. You can double check this by turning on your remote right now and flicking through the buttons. As you flick through the dip switches, this green should go to whatever your setting is on the remote. On the compass, if you set it up like I did, set rotation roll to 180 in this drop down menu, and then you can do a live calibration. Because you upgraded the firmware and you're not using the stock firmware, you can't use the cx20 trick to calibrate the compass. You now have to do it through Mission Planner. Alright, what else do I have to show you? In config and tuning. Alright, the biggest question I always get asked is the quadcopter won't arm. How do I fix it? And before you can even do an ESC calibration, you need to do this anyways. So depending what version of Mission Planner you have, you'll have different options in here. But in standard params, in this newest version, under arming check, has a check mark in all. So basically what it does is if you don't have a GPS signal, it won't arm. That's basically everybody's problem usually because they're in their house and they're trying to arm it or it's cloudy out. So what you can do is uncheck all, and you can just put check marks in everything except, I'm not sure why they add RC, because how would you arm it anyways, unless you're through trying to do it on your phone or something. But anyways, just leave GPS unchecked. Alternatively, in this version at least. In other versions, there's actually a drop-down menu where you can actually click on disable. This one doesn't have it. So what you can do is go to full parameter tree and go down to arming check and then set this to 0. This will disable all of them. So that's really up to you. So you can either disable all of them or just the GPS. It's up to you. And then write your parameter. And then if you go back to advanced or standard, that check mark's gone now. So again, it's up to you. So if you just want to have these ones here, you'd put check marks in these guys and then write your parameter. Okay, the next thing I get asked all the time is my motors are spinning when I arm it. So go back to full parameter tree and scroll down to MOT. So under MOT, you want to put this MOT spinned armed to 0. So by default, it's usually 70. So just set this to 0 and then write your parameter. Okay, another thing you want to go to is go to standard param. This one's totally optional. So under config and tuning, standard params, scroll down to, what the heck's the name of it? There it is. RTL altitude. By default, this is set to 1500, which is 50 feet. I set mine to 424, which is roughly 13 feet. The reason why I do this is when you're first testing out your quadcopter on the maiden flight, most likely you wouldn't want it on a return to home to go 50 feet up in the air. Just in case you're having a problem with it, say if the compass is off or something like that, it's not going to take off on the left or right and you're going to get into a panic and try taking control again. This way you're only 13 feet off the ground, so if it does happen to crash, everything should be fine. However, if there's trees and stuff in your path, it's going to crash into them. So that's why I say this is optional. I always leave mine at 424, even when I'm going in a park and stuff like that. If I'm out on big missions, then I put it back to the default. So just set it to 424, then write params if you want to, or leave it at 1500. Alright, the last thing I can show you guys in Mission Planner for now is in the initial setup. If you have a power module, go to optional hardware, then go to battery monitor, and pick voltage and current. Under battery capacity, set it to your battery size. For sensor, set it to your sensor that you got. This one's a 3DR power module. And then your APM version, and that's APM 2.5 plus or whatever, 3DR power module. And now in your HUD, if you go to flight data, you should get your battery voltage and your amps. Alright, that's about it for the video. I'm going to show how to do an ESC calibration next. Hopefully this was more helpful than my other video. It went a little long, sorry about that. I was going to try making it quick, but I just kind of like explaining things. And that's about it. Thanks for watching. Bye. Alright, before you calibrate your ESCs, I would suggest just to make sure you find your centers for all your buttons. You have a new APM now, so your old calibration shouldn't be useful anyways now. So to find center, just push it down twice just to see if you're on it. Then push it up twice. And that solid beep should tell you you're on center. Just to make sure, push up again, and you should hear that. So go all the way down until you hear it. The reason why you want to go down one more time is just to make sure you're not actually at the end of it, because it gives the same tone when you're right at the bottom. So it gave me a beep, so up. Same with this guy, to the right, back to the left, then go over once. I still get a beep, so go back, get the solid, same thing. Alright, so they're all good now. Now I'll show you how to calibrate your remote. Alright, before you do the calibration in Mission Planner, to calibrate your ESCs, the first step is to calibrate the remote. We just went over the centering all your switches here, so the next step is this. Set this SWB to 1, hold this one up, turn the power on. Those 3 lights are there, so now you'll want to go around in circles, back and forth. Just do that a couple of times. Okay, it's very important on this step at least, is you find the center. There. Then push this to 0. And turn it off. If you don't find the center, you'll never be able to arm it, and you might not be able to calibrate it in Mission Planner as well. Right, in this part I'm going to show you guys how to calibrate the ESCs, which I think is the safest way. Find yourself either a USB charging cable for your phone or something like that, a power brick, or a USB cable right into the computer. Now the first thing you're going to want to do is, it's a kind of a hassle, but you'll want to open up your quadcopter again and remove the power module, or if you're using this cable here that's coming off the motherboard, that would plug into port B. So just unplug the power module. This is important because if you don't do this, you run the risk of screwing up on your ESCs almost instantly. So it's up to you if you want to take convenience over kind of like safety. It's a gambling game, because I have done it originally without doing that, and I've never fried an ESC, but I was helping some guy on my YouTube channel and he ended up frying one of his ESCs. Alright, enough babbling. So take out your power module or take off the power source off the board, either or. The only power this APM should have is from USB. So I'm just going to plug in a USB cable into the side. You can plug it in underneath the quadcopter. It's important before you do this that you follow the other steps of calibrating the remote in Mission Planner. So my USB cable will just get plugged into the side of the APM eventually. And I'm just going to use a power brick. You also need your battery. I'm just going to move this up a little bit. And you should have your remote ready. So I'm only going to really show this button here because that's all you really need. Maybe I'll take off this guy. Alright, so follow these steps the way I'm doing it. If you end up not getting the 2 beeps right off the bat and one of the motors keeps beeping on you, once I tell you guys to move your remote up. Say if one of the motor keeps going beep, 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 don't push this down and push it back up thinking you're going to fix something, because what can actually happen is one of the motors or one of the ESCs can go into programming mode, and what you're actually doing is setting settings. So every time you go up and down, you might actually be going through a menu and you might be changing things. If you want more information on that, follow the programming ESC step-by-step I made. It's not for this quadcopter, but it'll let you understand what the beeps mean at least. I have no idea on this one yet. But anyways, alright. So the first thing you're going to want to do is plug in the APM. So the lights are on. I'm going to move it down like this just so you can see this button and the red light. This is just in case you don't have these 2 lights here. So what you're going to want to do is turn on your cx20. The light on your receiver should go solid. So you're going to want to arm it. You're going to want to have that other battery handy. Okay, so you're going to want to arm it now. Now the light up here is going to go solid. And you're going to want to go full throttle. Now you kind of have a time limit here, so kind of do it quickly. Plug in the battery. It'll make that beep sound. So if you end up getting this weird sound, don't push it down again. Because right now, one of the ESCs actually went into a programming mode. Now if you can hear the beeping, the one went beep, beep, beep. Beep, 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 beep. 4 beeps. That one's actually in a programming mode. So if I happen to push this down, I end up going into a different menu. Now if I happen to hit the default menu, it actually automatically sets all the defaults to it. And because these ESCs aren't open source, we don't know what the menu is. So I would suggest if it's like this, just unplug it. Kind of happy it did that, because at least I got to explain that. So if it happens, just unplug the battery, unplug the cable, the USB cable from the power brick or the APM, and try again. Alright, so I'm going to try it again. This is, you're going to have to keep trying until you get those 2 beeps right at the beginning. So everything has to be a motion. So first plug in the APM. Turn on your remote. Arm it. Wait for that red light to go solid up in the corner there. Go full throttle. Plug in the battery. Those 2 beeps there, and push it down. And that's it. After you hear that musical tone there, and if it's all quiet, you can move your throttle up. And all the 4 motors should turn at the same time. And then disarm it. Or unplug the battery. Alright, so that part's done.